Now everyone, we will continue with Gametogenesis, which is module 8.2 and the following modules. And for the thing that we have to take note of here is that the production of the egg cell and the sperm cell and the stages or sequences will be very important here. Now, first of all, let's talk about spermatogenesis and oogenesis. And take note that for spermatogenesis, it starts with the spermatogonium and then the primary spermatocyte, which then produces the secondary spermatocyte and the spermatid and the sperm cell. So it's quite easy to remember this. The gonium will always be the first, primary, then the secondary, and then the spermatid and the sperm. Take note, on the other hand, the oocyte, it also starts with gonium, but rather the oogonium, which then produces a primary oocyte and the secondary oocyte, the first polar body, and the egg cell and the second polar body. So let's go to the details of this one. Now, for spermatogenesis, just take note that the spermatogonia, which will be near the edge of the seminiferous tubules, will undergo mitosis to produce what we call as primary spermatocyte, which will be going through here. After that, the primary spermatocyte will undergo meiosis 1 to produce two cells, and this is what you call as the secondary spermatocytes. This is already haploid. After that, the secondary spermatocyte will undergo meiosis 2 and it will produce four cells, which we call the spermatids, which will then differentiate to produce the sperm cells. So you can see here another depiction. So you have your spermatogonium undergoing mitosis to produce two types. One goes back as a spermatogonia, while the other one goes towards as being a primary spermatocyte. Undergoes meiosis 1, you produce two haploid secondary spermatocyte, and the secondary spermatocyte undergoes meiosis 2, each one dividing into two, this one divided into two as well, to produce four of the cells, which would then differentiate into the sperm cell. So it's quite easy. Spermatogonium, primary spermatocyte, meiosis 1, secondary spermatocyte, meiosis 2, and then spermatid and then sperm cells. Take note that the secondary spermatocyte would be haploid and the primary spermatocyte and spermatogonium would be both diploid. Now for the female, it would be a little bit more complex, just a little. But just remember, it starts also with the oogonium, which is a diploid, which undergoes mitosis to produce two types of this. One returns as a backup for the oogonium, while the other one becomes the primary oocyte. However, it will stop here. It will arrest before birth, and then it will only start up again after puberty or the start of the menarche or the menstruation. So meiosis occurs or continues to produce the secondary oocyte and then the polar body, which arrests again, stops, and then will only restart meiosis when the secondary oocyte is ovulated, and then it would have been fertilized by a sperm cell, and then meiosis will be finalized to produce your fertilized egg cell and the additional polar bodies. So putting them together, we can now see here the analogy. You have the oogonium analogous to spermatogonium. Primary oocytes would be analogous to primary spermatocyte. The secondary oocyte and the first polar body would be analogous to the secondary spermatocyte, while the ovum and the secondary polar bodies will be analogous to the spermatids, and then the spermatids will then become differentiated into the sperm cells. So those are the important things we have to take note of. So again, the starting cell of spermatogenesis is diploid. Oogenesis is also diploid. So these are the oogonium. The ending cells are for spermatogenesis haploid. So this would be the spermatid or the sperm cells, and the oogenesis will have a haploid cells, which will be the egg cells. So we have here the four spermatids, so this would be the resulting cells, and one ootid or one ovum, wherein the other three would simply be polar bodies that will be disintegrating. For meiosis 1, spermatogenesis produce new primary spermatocytes, while oogenesis, an ovary contains already all the oocytes. So in the testis, sperm cells are produced daily, while in the ovaries, the oocytes are already fixed there ever since the development of the embryo inside of the mother's womb. For meiosis 2, the sperm cells are produced uninterruptedly in sequence, while in oogenesis, it is not completed without sperm cells. So there are several arrests at the same time, only completed when the sperm cell has fertilized the egg cell.